All right, now for addition and subtraction of matrices, okay? Now, there's one rule that you have to remember when you add and subtract matrices, and that is to add matrices, we add the corresponding elements. So they must have the same dimensions, okay? So if two matrices, you're asked to add them together, or even really subtraction, because the same rule applies when you subtract. If you're adding or subtracting two matrices, the dimensions must be exactly the same. If they're not, it can't be done, okay? And then all you do is you add the individual elements that match up in each matrix, or you subtract those elements. And it's so easy, and you'll be excellent at this, okay? We won't be allowing calculators on the majority of your tests and your quizzes for this, but if you have a little for function that you want to get out and sort of help you with some adding and subtracting right now, that's okay too. So here's two matrices. There's matrix A and matrix B. Notice that they both have the dimensions of a 2 by 2. So you can add or subtract A and B together, okay, because they're both the same. If we want to add A plus B, what that means is that we're going to add the corresponding elements, okay? If you have a 2 by 2 matrix and you add a 2 by 2 matrix, you're going to get a 2 by 2 matrix. So the dimensions will stay the same all the way across. So we're going to add the stuff that's in the first row, first column. Then we'll add the things that are in the first row, second column. Then we'll go to the second row, first column, and second row, second column. So it's super easy. The -5 and the 6 are in the same exact place in matrix A and matrix B, so we add those together. Okay? The 0 and the -3 are in the same spot, or in corresponding places, so we add them. The 4 and the 2 are in matching places, so those go together. And then 1 and 3 are in the matching places, so they go together. So you're basically adding the things that are in that have the same address, such as first row, first column, first row, second column, and so on. Okay? Well, then it's just simple addition. -5 plus 6 is 1. 0 plus -3 is -3. 4 plus 2 is 6. And 1 plus 3 is 4. And that's all that addition is. Okay? We can go to bigger matrices. Actually, before we do that, let's look at n plus O. Okay? That's on the back of your agenda. Right? Find matrix N and add it to matrix O. Do you see an issue there? I do. You can't do n plus O. Okay? N and O don't have the same dimensions. So, no solution, or does not exist, or impossible. However you would like to write that cannot happen. Or you can do what I just did and say no can do! Exclamation point. Pardon me. Now let's look at a different matrix. Okay? So here we've got two matrices we want to add together. They're both 2 by 3s, so you can add them. Okay? Now notice that second matrix is all zeros. Okay? When a 0 matrix is added or really subtracted to another matrix, you get that original matrix. Okay? And a 0 matrix is any matrix, all of your elements are zeros. Because all you're doing here is you're adding 0 to each of these, the 2, the -1, the 3, the 1, the 0, the -1. And 0 plus anything is that anything. So when you add the 0 matrix to any other matrix, you get what you started with. Okay? Now notice again that 0 matrix does have to have the same dimensions. Okay? Our first matrix is a 2 by 3. If the 0 matrix was not a 2 by 3, it would actually be no solution because those two things could not actually be added together. Alright, so for there to be a solution, your two matrices must have the same dimensions, no matter what's inside them. Subtracting matrices, it's the exact same thing. Okay, the main thing you have to be careful about is you're subtracting every element. Okay, so you can distribute that minus sign through the entire matrix and then just add them, or just remember you're always doing what's in one minus what's in the other. Okay, with subtraction, you just always have to be careful with your signs. So let's look at these two matrices. Notice they both are 3 by 2. And since they're both 3 by 2, we can subtract them, and we're going to get a 3 by 2. Okay? And we do the exact same thing as addition. You subtract the things in the same spots. Okay? The elements that share the same address, you're subtracting those. So we're going to do 1 minus 1, because they're both first row, first column. They're in corresponding positions. Then you've got 2 minus negative 1. Don't forget when you subtract a negative that that's going to actually turn into a plus. Okay? Then you've got negative 2 minus 1 and 0 minus 3. That's your second row. And when you jump to the third row, you've got negative 3 minus 2 and negative 1 minus 3. And again, then it's simple algebra. 1 minus 1 is 0. 2 minus negative 1 is a positive 3. Negative 2 minus 1 is negative 3. 0 minus 3 is negative 3. Negative 3 minus 2 is negative 5. And negative 1 minus 3 is negative 4. Okay? Take a look at the next slide. Okay, here's some practice problems. Take a second and let's do this first one, and then we'll check. So the first thing you should be doing anytime you're adding or subtracting, you need to make sure that your dimensions match all the way across. Because if they don't match, you're done. Alright? But in this case, they do. They're both 2 rows, 3 columns. So they're 2 by 3s. Does your answer match mine? Excellent. Let's move on to the next one. The next one, we're actually doing 3 different things, or really 2 things. Okay? We're taking matrix T and we're adding it to matrix U, and then we're subtracting matrix S. Okay? Well, order of operations, guys, when it's adding and subtracting, you just go left to right. Alright? But before you do that, you need to go to that back of your agenda, because that's where we're pulling these matrices from. First off, you want to make sure that all of your matrices have the same dimensions. Otherwise, you can't add and subtract them. Okay? And when you check that, you should see that T, U, and S are all 2 by 2s. So you can do your math magic and get an answer. So get that done real quick. Did you get the 2 by 2 matrix? That is 13, 11, then negative 8, 10. I hope you did, and if you still aren't done, feel free to pause the video, finish it, and then check, okay? Now, let's talk about the additive inverse, okay? An additive inverse is what you add to something that ends up giving you 0, okay? Well, if you have a positive number and you add the negative, doesn't that always give you 0? Like 2 plus negative 2, that would give you 0. So the additive inverse of a matrix is just the opposite of the original matrix. So if A is this 2 by 3 matrix, the additive inverse is the opposite. And all opposite means is you change all the signs. And the way you write that is instead of A, it becomes negative A. and you distribute that negative throughout every element inside your matrix. So that becomes, instead of a positive 1, it's now a negative 1. 0 remains the same. Then you have -2, -3, 1, and -5. This is actually, this whole distributing of the negative there, this is an example of scalar multiplication. And all scalar multiplication is when you take a constant and you multiply it by a matrix. Okay? So like in this example that you see, you have K times that big 3 by 3 matrix. Well, all you have to do is distribute K throughout every element. So what you end up with is 1K, 2K, 3K, then -1K, -2K, -3K, 4K, 5K, -6K. That's your scalar multiplication. So you've got some examples here. Okay? If we want to take 3 and multiply it by your matrix, you just distribute the 3. So 3 times -3 gives you -9. 3 times 0 is 0. 3 times 4 is 12. And 3 times 5 is 15. Same thing with no matter what's inside your matrix or outside. If you're multiplying something on the outside by something inside a matrix or just by a matrix, it's just distribution. So when you do 5 times this 3 by 3, all you get is 5, -10, 5x, 20, 5y, 5, 0, -25, and 5x squared. Can't do anything with the variables because all you're asked to do is the scalar multiplication. So you leave it there. Again, pretty simple, right? All right, so this ends, or we've now talked about the basic stuff in the first video. Now we've done addition and subtraction, which have to have the same dimensions for us to add and subtract matrices. And we've talked about scalar multiplication. There's one more part we have to do, and that's going to be in this last video. And it's solving matrix equations for x and y. Okay? So take a quick little break, take a deep breath, and let's finish up our notes with video number 3. Okay?